Hey everybody, we're back again, and it's just a short time from when we filmed the last video. Alex is hungry, and he has so many questions about pointers and about dynamic memory allocation, and I'm here
Great.
to
Yeah.
hit the nail on the head, and hopefully we can get to some more things today. So we're going to talk about pointers again, and all these exciting things. And like I said, this is one of these things that's very abstract to start off, and you just got to stick with it, and it will come to you, I promise. So what we're going to do, I'm going to share my screen with you again. And I didn't, since we're doing this right after the last tutorial, uh, most of this is just going to be just straight coding and talking through. And this lesson is going to be talking about what we were discussing at the end of last tutorial, which is creating objects dynamically. And what that means is that as we were discussing in the last tutorial, not all things in your program, in your C++ app, as they get bigger, are going to exist throughout the lifetime of the program. So you're going to have things like we were talking about the video game example, where we have maybe players that we create, enemies that we create dynamically, and then we don't need them anymore. So we're able to basically free up that memory, free up those resources for other things that we may need to do. Okay, so as I said before, I haven't really prepared a presentation, so to speak, for this, but we're going to do high-level thinking, and then we're going to do a code walkthrough on this. So we're going to return to the code that we had done in our last tutorial to discuss this. So as I was saying to you before, one of these things that we have at the moment, we have this very basic program, and as I was saying to you before, I call upon people watching this tutorial, and for you, Alex, to use your imagination a little bit, and these things, I think, make everything a little bit more real than if I were just to talk about ints and bools and int pointers, and that's something that I see when I was trying to learn about pointers. One of the toughest things to really understand is why I would use a pointer. So there are a lot of tutorials that talk about the syntax of pointers themselves, but there aren't a lot of tutorials that really talk about why would you use a pointer and when would you use a pointer. So that is what we're going to try to tackle today, is the why of pointers. So as we were saying before, in this particular simple program in int main, the way that it would work, as we have it, is that our program would create an audio track, and then it would analyze the track, and then the program would finish, and everything would end, and everything would close, and that would be it. Okay, so what we want to do is we want to imagine a more complex program for a moment, where what would we be able to do is we'd allow the user to be able to choose a track that they could actually analyze, and that maybe after analyzing the track, they want to do something else with the track, or they want to go and do some other work or do some other thing in your app. Okay, that the app doesn't just finish after you've finished analyzing the track. So so we could just say do some other stuff, right? So that's what we're talking about now, right? So the first thing that we would talk about is maybe we would have some type of menu where we would allow the user to actually open up or choose a song that they want to analyze, right? So
Yeah.
user chooses a song. All right. Now what we can do is that we don't need this audio track to actually exist at the start of the program, right? What we could do is we could actually just wait till a user chooses the song, and then what we could do is we could actually do what's called dynamic memory allocation, which means that once the user chooses a song, then we actually create the memory space for this thing on the fly, like while the program is running. Okay, so it doesn't have to be reserved at the very beginning of the program. Okay, does that make sense to you? What I'm saying so far?
Yeah.
Yeah. So the way that we could do that. So I'm going to show you there's a quote unquote old school C++ way of doing this, just to show you kind of what happens when you're doing this, and then I'm going to show you the correct, quote unquote, correct way to do this. Okay, the recommended way to do this. So what we could do is, and this starts to get a little bit heavy in the syntax, so I hope you can bear with me when we get into the later stages. So first thing that we could do is we could say audio track. So user chooses a song, and then we could say audio track, and then there's this keyword called new. And what we do here is pretty much exactly what it says, where what we're doing is we're saying, okay, let's create a scenario where the user chooses a track, and that now once they've chosen the track, we create a new audio track on the fly. Okay? Does that make sense so far?
Yeah.
Yeah? Any questions about that so far?
I have one question, but I'll reserve it after you're done.
Okay, cool. So what we've done there is we've actually created a new space in memory where we've actually created this audio track object. Okay. If I do this audio track, this has to exist when I actually compile the program. So it has to exist at the very start of the application when I run the application, right?
Sure.
When I'm doing it like this means that I can actually do this sometime while the program's running. I don't know when the user's going to when the user's actually going to select a track, but once they do, then I can reserve memory and I can actually allocate the space that I need to accommodate this audio track. Okay, and then from here, then I can run my method, right? I can just say analyze track. Okay, and then I could do some other stuff. Now, one of the things that you may hear about is this this phrase called memory leak. Okay, so
Yeah.
have you heard that phrase before?
Yeah.
Okay, so what this means, let's say that this audio track is doing things, and that let's say that we're done using the track, right? We've created it, we've done stuff with it, we've allocated the space in memory. Now that space is going to be occupied until we free it up manually with this way that we're doing it now. Okay, so what happens with a memory leak is that people may use this method, and what they do is they forget to actually free up the space again when they're actually finished using the track, and that or finished using this object. And then what it does is it ends up hogging up memory in their application, and they're not even aware that it's doing this. Okay, so does that make sense to you?
Yeah. I mean, I've seen a couple programs run from other people, and that exact issue happened where the program's running, and then somehow I don't even know how they managed to pull this off, but somehow the program continuously uses more and more memory until it crashes. I mean, in some cases, it's even crashed the computer itself.
Yeah, exactly. And that's what happens, is that you get you get where these resources may be doing things in the background that you're not even aware of, and what it's doing is that it's hogging more and more memory and more resources until it could actually crash the application. Okay.
Oh yeah, that was actually I wanted to ask this because this kind of relates to that principle. But let's say we have an audio track. It's loaded in. The user does everything with it, and then they're done with it.
Mm-hmm.
Is there any need to kind of deload, if you want to call it that, deload
Yeah.
that track
Yeah.
so that it's just back to null pointer?
Yeah, yeah, exactly. So, so what you can do is, so once again, this is the quote unquote old school C++ way of doing this, and this is not the way that I would currently advise that. So this is just to show you what's happening. Okay, so
Sure.
in the old days, before I was ever developing, what you would have to do to actually free up that memory is you'd have to use the keyword delete, and then you delete the track. Okay,
I see. Okay.
and that's what will actually free up that space. Or a more correct way of saying this is mark it, quote unquote, mark it as free. So it's possible that if I needed to get if I wanted to do analyze track after, so this will be something that would be dangerous, right? Where I've marked the track as ready to free that resource, and then I try to run a method back on that again, right? So that would, so if I ran that, then that would run into undefined behavior territory, right?
Right.
Because I've already freed up the resource. Okay, does that make
Yeah,
sense?
it's just it's just like SSD where, from my understanding, it doesn't actually, like if you put a picture in there and then you quote delete the picture's still technically there, but if you put a new picture there, it'll basically overwrite what was previously in its place.
Yeah. So the key thing to understand here, and this goes into kind of the far bounds of like my understanding of what exactly happens under the hood, which is that when you actually mark that space, that box as when you actually say delete track, it doesn't actually quote unquote delete it. It just marks it as free,
right. Yeah.
as like you can write over this memory now. Okay, so it doesn't delete it per se. So delete is kind of a misnomer. It's a little bit misleading in that way. Okay, so so that's what you used to have to do back in the day. But as you can see, it can be very dangerous, because even when I do analyze track after delete, there's nothing. I don't think there's anything that's going to stop it from me running again, right? And see how that's dangerous, because now I've marked that as ready to be overridden by something else, and that I've ran a method back on something that I've marked as delete, and it lets me do it. Okay, so that's dangerous. We don't want to do that. Great. So we've talked about why this approach is dangerous and why people don't really use this method for allocating memory dynamically anymore. Okay, so any questions about that so far?
No.
Okay, cool. So now what we're going to do is we're going to talk about a way that C++ has actually made it safer to dynamically allocate memory. And what it does is that it will actually call delete within itself to actually automatically delete the track or automatically delete your object when it actually goes out of scope. So it's kind of automatic memory management, so to speak.
Oh, okay.
Okay.
Interesting.
The only thing about this is that for somebody who's starting out, the syntax may be a little bit more, a little bit longer. Okay, but you'll get it. Okay, it may look a little bit intimidating at the start. So what we were talking about before was audio track, star track equals new track. So now the way to do it now is we could say, I will show you the long way and then we can shorten it up. Okay, so we have this thing in the standard library. Hopefully it's included with IOStream. And it's called stood unique pointer. Okay, so stood unique pointer, and then you have to have this angle bracket, like a little pointing sign, and then you have to tell it what type of pointer that you want it to be. So, if you want it to be an int pointer, in this case, we want it to be a audio track pointer. Okay, and now we can call it track, and so we have that, right?
Mm.
Okay. Any questions about that so far?
So it seems like the obvious, just in my mind, the obvious caveat of using that method is that it would, because it automatically deletes the pointer after you use it, you can't use it elsewhere. Is that correct to assume?
Yeah. So we'll try that and see what happens, right?
So is that why they've chosen to maintain the quote old method of pointers?
The reason that they've chosen to maintain the old method is for the C++ Standards Committee has a policy of trying not to delete older features, because what that would do is if they said, okay, we're not going to do that anymore, and then people updated to their new C++ version, then it would just break a whole bunch of code bases. So, and some of these code bases are probably millions of lines long. So it's too much to actually update everything to the new way at once. So yeah. So this audio track, so this stood unique pointer audio track is just this first part of this part right here.
Oh, there's more. Oh, okay, that makes sense.
So what I've done here is I've made there are two parts. There's the declaration, and then there's the actual what we would call memory allocation part. With this particular line of code, audio track star track equals new audio track, I've done both in one line of code. I've declared it, and I've also allocated memory. Okay, you can actually do this. You can actually do this in two steps, and maybe I should have mentioned this before. So let me just take this out for a second, and we could actually do this. Okay, so we could say audio track star track, and it's best practice to always initialize any pointers to null pointer. Okay. Now at a later point, I could say track equals new audio track. Like that. So this could be like way later down the line. And then that allocates it. So this is the declaration, and then this is memory when you actually allocate it. Okay? Does that make sense?
That makes sense, yeah.
Okay. So going back to the correct way to do this, so take this and now delete it out of your memory bank and do not do that. Okay, so now we're going to do it this way. Stood unique pointer, and then you have to tell it what type of pointer that you want it to be, audio track, and then we would call it track, like this. And then later on down the line, now this is where, once again, it's a little bit longer. Okay, it's not too difficult. You could say track, and then to allocate, you have to do this. You have to call this other function called make unique. This is what actually does the memory allocation. So it's once again stood make unique and then you have to tell it what type of unique pointer that you want it to make, which is audio track. Now this args part, this is if I had something that I needed to do to initialize the audio track, I would put it in. I would put it in there. But since there's nothing, then you just open and close parentheses like that.
I see.
And now you're good. Okay. That's it. And you can actually do this. You could actually do this in one line as well. So one of the things about C++ is there are loads of different ways to do the same sort of thing. So this is another way that you could do it here. And as you can see, when the lines start getting longer, they start separating out into two lines. So you could do this. Another way that you could do, one thing that we haven't talked about is there's this thing called auto, which will actually deduce what type you're trying to make it. We'll do a whole tutorial on auto at some point in the future. But
I remember
auto
was. I remember you mentioning auto was dangerous, and I think.
No,
auto.
Auto is not dangerous. Auto is great. Auto is awesome. Yeah.
Oh, okay.
It actually keeps you from making mistakes and from things getting too complicated. So, like you notice how I did auto track, and that's quite readable. This feels quite complicated to me.
Sure.
So when you're reading through code, like this feels much more readable to me. But auto is something that we could talk about a little bit further down the line, or even pretty soon actually, because auto is amazing. And there's a rule in C++ called almost always auto, which means that nearly any time that you want to use, that you're able to use auto, you should probably use it. So,
interesting.
Yeah, so that's that. I'll keep it the old way since we aren't really familiar with auto just yet. I'll put it into two separate lines like that. So so that's how you use a unique pointer. And the problem with this is that I have this in my int main function, and I don't really know on the fly how to make it because what happens is that this allocates the memory line 28 allocates the memory, and then the problem is that I would have to come up with some sort of really contrived way of track going out of scope and then trying to use it later on to actually make it make sense. But trust me when I say that when you hit the close brace on line 29, what that does is that automatically deletes track. So it automatically frees that resource. Okay, and then what you could do is you could do analyze track, and I'm not sure if I could just pass in track like this. Let's see, or if I need to do track. I think I have to do track.get. Yeah, so once again, it's just a little bit different syntax, which is that to get the pointer. So we have this analyze track, which calls for a raw pointer to a track, and this is a unique pointer, right? So it's not quite a raw pointer; it's a little bit different. But now you have this there's this method that will get you the raw pointer, which is track.get. Okay. Yeah.
Yeah, it's a bit hard to wrap my head around it until I get some application of this, but I'm sure we'll get there.
Yeah, and one of the key things to know is that to start off when you're doing C++ programming, and especially if you're using a framework, a lot of times you probably won't be really making a whole bunch of pointers. So the rule of thumb when it comes to pointers is try not to use them unless you absolutely have to. But this is more for in a framework, like if you were using Juice, or if you were using, there's another framework called Qt as well, where you're going to have functions like this, where it's going to say we need to take in a pointer to a track or a pointer to something, and then the big thing that you have to understand is how do I pass that data in, so if audio track is a reference, so if we say audio track like that, so that's something that is a reference. And once again, when you have a reference, but it wants to take a pointer, now you have to point it towards a memory address. If you have a audio track pointer, now it would just take the audio track pointer as the argument. If you had a stood unique pointer, then you have to use track.get. And that's something that's like that's a muscle memory that you will get over time.
Sure.
Yeah.
So
yeah, go ahead.
As someone who has, I'm sure you've reviewed code bases by other people. What would you say is the number one mistake people make when it comes to pointers?
I would say that the number one mistake that people make in regards to pointers is I would say it's a tie. The first one is using pointers when you don't need to use a pointer. I would say that's probably the number one mistake that I see is people, they say, oh, we got this thing, and you try to overcomplicate the code and you try to use pointers in situations where you don't need to use pointers at all. Okay, so that's number one mistake. Number two mistake, I would say, is using raw pointers when you don't need to use raw pointers. Try to use a smart pointer, like unique pointer. Okay, but most times, and that will keep you out of trouble when you use a smart pointer. But when you try to use raw pointers, and then you try to go and you try to access an object that has already been marked as being freed and marked as deleted, then that just runs you into a whole bunch of problems.
Yeah.
So there's also this in some code bases they have so a lot of larger code bases, they have a policy of how they do their functions. So when something needs to take a reference, so some code bases you may see they prefer to do everything with references. So everything you'd see would look like that. Or and then in other code bases, they would say we want it to be pointers like that rather than references. So once again, not something that you really need to know right now, but that's something further down the line.
Sure. All right.
Yeah. Cool. Any other questions there?
No, I think that's everything.
Yeah. Cool.
Yeah.
So that's part two, is just memory allocation, dynamic memory allocation. If you have an object or you have a class and you want to dynamically allocate it, that's how you do it for now. And stay away from the raw pointers. Raw pointers are dangerous, and that's really it for this tutorial. Okay.
All right then.
Cool. So that's where we're going to end this one. And I hope you enjoyed that. Did you have fun?
Yeah, that was a bit convoluted, but
yeah,
I think it'll get nailed down once again you start actually applying that.
Mm-hmm. Absolutely. It's all about application and experimentation. Cool. So that's where we're going to end this tutorial. I hope you enjoyed that. Be sure to like and subscribe, and we will see you next time.
All right. See you later.